As you all know that I am going to start a course on the G+25 residential building design in ETABS. Okay, in that I will discuss about because as you know that how means how many types of loadings are coming into our picture when we are going to design a high-rise building. So for the tall building structure, for tall buildings design, first of all the code is also a different for this thing. IS 16700, I think this code is for the tall building design. So according to that, we have to use the section modifier also in our ETABS sections. Okay. So these things are also available in that. Like if our building height is more than 70 meter, then we have to follow this code. Okay. For more than 50 meter. Now, as we know that the course is totally based on the tall building design. Now, what type of things are different with our like general buildings? Okay, like small buildings. So, what is the difference? So, difference is first we have to do. So, let's I discuss all the load cases. Second one, 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 second one is live load. That is also same IS 875 part. Not much more because these are just the same. Third thing that is our wind load. So this is a very important thing because for the tall buildings, like if I want to say that when we have to do the dynamic analysis, because the in one below there are two types of analysis are available. Like first is our static analysis, the static analysis. Second is our dynamic analysis of it. So when our building height, if you say, so the factor that governs that dynamics analysis, that is aspect ratio. What is the aspect ratio? Let's this is my building plan. Okay, this is my A and this is my B and this is my elevation of the building. This is ground and this is like I am seeing from here. So this is my A and this is my height. Okay, if your h by minimum of A comma B, these are the base dimensions. A and B are the base dimensions. Okay, so जो भी इन दोनों में से minimum होगा, we have to take the minimum from A and B and we have to calculate the aspect ratio that is our height by minimum of A and B. Okay. If it will be come out as more than 5, then we have to do our dynamic analysis. It is also given in code. If you want to check that, then you can also check in IS 875 part 3. It means 2015. It means when we have to do the dynamic analysis also. If these are the factors, means aspect ratio will come out more than 5. First point. Other thing is that if your first mode frequency, okay, first this is also called fundamental frequency. First mode frequency will be come out as less than 1 hertz. What is the frequency? Frequency is just like a 1 by 2. Means inversely proportional to our time period of the building. Okay, so first mode building means T1 I have to give the name. F1 will come as 1 by 2. So that is our first mode frequency. If this will come out as less than 1. If this value also will come out as less than 1. Then you have to do what? You have to do the our dynamic analysis for the building. So for the dynamic analysis, we have to do a lot of things. So let's I show you the Excel sheet for that because we can't do this thing without the Excel sheet. Okay. So I have made one Excel sheet to do the dynamic analysis. So let's I show you. So the Excel sheet is just made by the use of IS 875 part 3. Okay. 2015. That's 1 second. Yeah. So these are long Excel sheet that you can see in that we have to check the long and across winds, okay, along for X and for Y and for these are like some smaller sheets that are just used for the torsional irregularity checks, soft story, weak story, all the things, right? Okay. So in this, all the things are available. So these are like a small thing, but main things are to apply the windows and lot of formulas are available, dates are available, these charts are also available in code. Let's I show you that thing also. So at the result, we got these are the values. At the end, we get these values. So in this course, I will provide that Excel sheet also because without this Excel sheet, that is very difficult to assign the window. for dynamic analysis. Okay, so that thing also I will provide for X tires and the Y tires. So let's I show you the code also. Means in the code where are these things? So in the desktop, let's I open the code ISO 75 part 3. Okay, so here you can see when we have to do the dynamic effects, means dynamic analysis. If building and closed structure with a height to minimum lateral dimensions that I have shown you, A or B, okay, is more than 5, then you have to do the dynamic analysis. And the first mode is less than 1 hertz. Then also you have to do the dynamic analysis. These things and how you can do the dynamic analysis. So there are a lot of formulas for that. So let's I show you. So from here we have to start. Means for the along wind response, we have to calculate these all the things. This is the force. In that there are a lot of factors, A Z, PD dash, G dash. So these are also have some formulas, and in between means okay, inside there are a lot of formulas. There are a lot of things that I have to discuss in this course. This is like this is all the process we have to do. So for that I have made the Excel sheet. These formulas, okay, these charts, so that will be come into use. So there are 3 to 4 pages are available to do the dynamic analysis of wind. So by manually we can't do. Okay, we have to use the Excel sheets. So I have already made the Excel sheet. I will provide that when if you register for the course, and you can design your high-rise building for the wind damage, for the dynamic wind also. Okay, so there are two loads like static and dynamic. So we have to define these both things. Okay, means for this also because we have to design this building in ETABS. So in ETABS, if you see the plan, then in plan you can see these axes, X and Y, and Z will be in the story height. Okay, in the direction of vertical. Okay, so in the X and Y we have to apply the wind load. So the loads patterns that will become so plus X, second one minus X, third one plus Y, fourth one minus Y. These are the static. Now we have to do this for the dynamic also. WL dynamic. So let's take on title as this one. So in this 4 cases also we have to make for the dynamic. So this is a new thing that how we can analyze as a dynamic for our structure. Okay. So I will go one by one from start to end. So we have to do the wind analysis also by the dynamic way. And the fourth load combination after that, that is our earthquake load. So earthquake load is also having some issues because there also like some static analysis. So that thing also we have to do. And dynamic analysis also we have to do because in IS 1893, code is our what? Code is our 1893 part 1 2016. In 1893 code, there are some parameters that goes for the dynamic analysis. So let's I show you that thing also. Okay. Yes, this one. So in this one, you can see that when you have to do the dynamic, you have to do the dynamic if your building height is means when you don't need to do the dynamic analysis. If your height is less than 15 मीटर for the seismic zone 2, that's it. अगर आपका बिल्डिंग का हाइट 15 मीटर से कम है वो भी सिस्मिक जोन 2 में तो ही आपको सिर्फ स्टैटिक एनालिसिस करना है अदरवाइज यू हैव टू गो विद डायनामिक एनालिसिस लेट्स आई शो दैट थिंग आल्सो so if you see here by search the dynamic word you can check in building 3 dimensions so these all the things are here like let's I show you if I go down yeah this one employed also the height of the so okay this is okay now this one also in a building with mass irregularity and located in seismic number 3, 4, 5. You have to do the dynamic. Okay. Because for zone number 2, seismic zone number 2, if the height is lower than 15, then you can do static. But otherwise, in other cases, you have to always do the dynamic analysis. How we can do that? So the dynamic analysis we can do by 2 ways. Like first option, we have the time history analysis. You can see in the code also. In code also, these both things are available. Okay. We can do dynamic analysis in 2 ways. First is our time history analysis. What is time history analysis? So it is having also some concepts so that I will cover these things in this course. Second is our response spectrum analysis. Okay, so we have to use the plots of spectra. Spectra plots we have to use for this thing. Response spectrum analysis. So it is a more accurate. I should say response spectrum analysis is more accurate with time history analysis. Okay, so that thing also. So these both thing I will cover with the help of IS 1893 and in our ETABS software. Okay, so this thing also we have to do, and static analysis is just a easy part. We can do just by defining the zone factor, importance factor, response reduction factor, all the things, damping ratio. By that, you can do this, but for dynamic analysis, we have to do some other things in ETABS and StatPro in any other software. Okay, by take care of these things, time history analysis and response spectrum analysis. In response spectrum analysis, I will show all the manual calculation also. That's how we can analyze our structure for time history analysis and for response spectrum analysis. I will show all the calculation by manually. Means we in this course we will go with deep knowledge through the step through our software also. Okay. E टैब में भी हम करके देखेंगे और हम मैनुअली कैसे करते हैं how we can do this manually. So that thing also I will cover in this course. Okay. So after that we have to make our all the load combinations according to our IS 456 code. Okay, and we have to, when we are modeling, then according to our IS 16700, we have to provide some section modifier. What are the modifier? It means we are just assuming that our beam for like a torsional stiffness, like a moment, 2 stiffness, moment, 3 stiffness, having some less strength. Okay, we are just assuming less stiffness so that our structure will be safe. Okay, it means we are in safe side. So let's we are taking some higher factor of safety in our members. So that's I also in IS 16700. Okay, so these things are also covered in this course. Means how much and which type of factor section modifier we have to use in our sections according to our IS 16700 tall building design. Okay, so that is also in our code. After that, you have to make the load combinations according to our IS 456 and 12. After doing all the things, we have to check. Okay, we have to check because we have to take care about the serviceability check also. So how we can do serviceability check? So there are some provisions like your overall displacement. Okay, means maximum displacement of the building should not be more than h by 500. So there are three types. So for the wind load also the parameter is given. Means due to the wind load this node should be more than h by 400, this type of like h by 250. So these are also going in the code for the cake. Means these all the associated check I will cover. Okay. I will show you these all the checks also. That's how we can do the checks in our ETABS. There are some tools like storey drift flow in like with this name in our ETAB. There are one tool. By that you can see the story flow. Okay, along the height, how much reflections are going on due to a specific type of load. Okay, so this thing also will come, and after these all the things happen, okay, our building is ready because we have to first of all design. After that, we have to check that these are permissible range. These are in permissible range or not. Okay, so this thing we will do, and after we are going for detail. So detailing our will be according to our IS 13920 code. Okay, tactile detailing code we will use. So according to that, we will detail our members, beams, columns, shear walls, staircase, beam, columns, shear wall, footings. Okay, so these are 4 to 5 slabs. Slabs is also there. So 4 to 5 main members we have to design in this case. And staircase you can design by the use of Excel sheet also. I will provide that. Means how you can make the Excel sheet. So staircase you can design by that. Some other Excel sheet also I will provide like isolated footing, how you can design by the Excel manual isolated footing, eccentrically loaded footing. Okay. And wind load calculation that gust factor because the gust factor will come into the picture when we are going for the dynamic wind analysis. Dynamic wind analysis. Okay. So these all the things I will cover in this course. We will go like I will take a plan of the real time building that I think the name of that building is Daruchaya Residency in Jaipur, I think, on the Ajmer Road. Okay. So that plan I will take for our structure. That's like I will design for G+25. In that there are some shear walls, some beams, means beams, columns should be there, but shear will be also there. So according to that, we will do all the things from start to end. Okay. Means this is the whole process that we have to do for every type of building. Those have these type of parameters like more than height 50 meters. You have to use the tall building design parameter, tall building design code. Okay, IS 16700. So by this course, you will understand all the things that are going in the site by a structural engineer, that how we can design a real-time building. Okay, high-rise building. You can design any type of building that has the height less than 250 meter, because up to 50 meter to 250 meter, we can follow this code. The first line of this code, it says that if your height of the building is more than 50 meter and less than 250 meter, then you can use this code. Okay, there is just a first line of the code is there. This thing. That's denote that for 50 to 250 meter, you can use this code. For over 250 meter, you have to go with another course. Okay, so that's a different thing. But I will cover like 50 to 250 meter height, what you should do. Okay, because like if your height of the each story is like 3 meter, that's height, assume that height. So if you divide it, then it means like it is your 80 story, at least 80 story, 80 to 82 story building you can design. 82 story building you can design by this, okay, with the help of the this code, IS 16700. Okay, so is that fine for that? If anyone who is interested for join this code, they can register. And by for register, you have to just do me WhatsApp. Okay, you can do WhatsApp to me on this number. And the price, as you can see, this is the price. And already those who have registered for my last courses, for that the price is low, like that price is reduced by 500 rupees. So for that the price is 1,099. Okay, 1,999 rupees for them who has registered in my last course. And that this seminar will be going like 10 days. You can assume that this seminar will go 10 days, and the time will be like a evening time. Okay, according to your jobs, because you all are doing the job in your cities. Okay, so for that I will assume the time like 10, 9 p.m. or 10 p.m. Okay, for every day. So it's like a approx 10 days course, and in that I will cover these all the things, real time building design plan I will take, and at the end of the course I will give one assignment on that also. So you can practice for that. Okay, one assignment plan of the building I will provide to you. So for that also you can practice your model in this same manner. Okay, so these all the things I will cover in this course. How to do the model analysis. Okay, so that also in this course also, because model analysis is necessary for the tall buildings. Okay, so thanks to if anyone who is interested, they can enroll by just putting a message to me on the WhatsApp, and they can contact me also if they have any doubt. Okay, so.